Happy morning, students. Today we are going to see the new chapter Quadrilaterals. Quadrilateral is a four-sided figure with four vertices, four adjacent sides and four angles. So in this figure, angle A, angle B, angle C, angle D, we have four angles and four vertices A, B, C, D and four adjacent side AB, BC, CD and DA. Now we are going to see the various types of quadrilaterals. So the first one is parallelogram, a quadrilateral in which both pair of opposite sides are parallel is called as a parallelogram. So which can be written as by the symbol. So in parallelogram PQRS, we have PQ is parallel to RS and PS is parallel to QR. Second one, rectangle. It comes under parallelogram. So it is defined as a parallelogram, one of whose angle is 90 degree is called a rectangle. So this rectangle PQRS, we have PQ is parallel to SR and PS is parallel to QR, and we have taken one angle PS 90 degree here. Now coming to the third one, square. A parallelogram whose all sides are equal and one of whose angle is 90 degree is called a square. So he has drawn a square where he has drawn all sides were equal. So in a square we have AB is equal to BC is equal to CD is equal to DA, and we have taken one of the angle A as 90 degree. Fourth one, rhombus. A parallelogram having all sides equal is called a rhombus. So here we have drawn a rhombus DEFG where the opposite sides are parallel and all sides are equal in length. Fifth one, trapezium. A quadrilateral having one pair of parallel sides and the other pair were non-parallel. So this figure ABCD having a parallel side AB and CD and non-parallel sides AD and BC. So ABCD is a trapezium. Sixth one, isosceles trapezium. If the two non-parallel sides of the trapezium are equal in their length, it is called as a isosceles trapezium. Next one, we are going to see angle sum property of a quadrilateral. So he has given the sum of the angles of a quadrilateral is 360 degree. So we have drawn a quadrilateral ABCD. We want to prove that in a quadrilateral ABCD, the sum of the four angles, angle A, angle B plus angle C plus angle D is equal to 360 degree. Now coming to the solution, consider a quadrilateral ABCD. We want to prove angle A plus angle B plus angle C plus angle D is equal to 360 degree. We are going to join the diagonal BD. So I am going to separate this quadrilateral into two triangles by the diagonal BD. So we got two triangles ABD and BDC, where in triangle ABD I am marking angle ABD as 1 and angle ADB as 2. Now coming to the proof, since the sum of the angles of a triangle equals 180, in triangle ABD we have angle A plus angle 1 plus angle 2 is equal to 180 degree. And we are considering next triangle BDC, where in BDC I am naming the angle CBD as 3 and CDB as 4. So I am writing here by angle sum property, angle 3 plus angle C plus angle 4 is equal to 180 degree. Adding both the equations, we get angle A plus angle C plus angle 1 plus 3 plus angle 2 plus 4 is equal to 180 plus 180, it becomes 360 degree. Now you see in the figure, angle 1 plus 3 is equivalent to angle B, angle 2 plus 4 equivalent to angle D. So I am going to replace angle 1 plus 3 and angle 2 plus 4 as angle B and angle D. So we get angle A plus angle C plus angle B plus angle D is equal to 360 degree. Hence, I proved that the sum of all four angles inside a quadrilateral is equivalent to 360 degree. Now we are going to see properties of a parallelogram. So the first property, he has given us theorem 8.1. A diagonal of a parallelogram divides a parallelogram into two congruent triangles. So I have drawn the parallelogram ABCD with the diagonal AC. I am dividing the parallelogram into two triangles ABC and ADC. So we are going to prove that these two triangles are congruent. Now coming to the solution, given a parallelogram ABCD in which the opposite sides are parallel. So I have written that AB is parallel to CD and AD is parallel to BC. We want to prove triangle ABC is congruent to triangle CDA. So by construction, we are joining AC diagonal. Now consider triangle ABC and triangle DCA, where I am marking angle BAC as angle 1 and angle 3 to BCA, and similarly angle 4 for angle DAC and angle 2 for DCA. Now coming to the solution, in triangle ABC and triangle CDA, AB is parallel to CD, and if you take AC as a transversal, I can relate angle 2 and angle 1 as alternate interior angles. Take BC and AD as the two parallel lines cut by the transversal AC, we get angle 3 and angle 4 or alternate interior angles. So I am writing here, since BC is parallel to AD and CA cuts them, we have angle 3 is equal to angle 4. Consider triangle ABC and triangle ADC. We find that angle 1 is equivalent to angle 2, where angle 1 and angle 2 belongs to the triangle ABC and ADC. Similarly, we find angle 3 is equal to angle 4. Then I have AC as a common side to both the triangles, where these two angles lies on the common side AC. So by ASA congruence, triangle ABC is congruent to triangle CDA. Hence I proved that the diagonal divides a parallelogram into two congruent triangles. Theorem 8.2. In a parallelogram, opposite sides are equal. We drawn a parallelogram ABCD with AB is parallel to CD and AD is parallel to BC. So we are going to prove that AB is equal to CD and BC is equal to AD. Now coming to the solution, when ABCD is a parallelogram in which AB is parallel to CD and AD is parallel to BC. We want to prove that AB is equal to CD and BC is equal to AD. Construction, join the diagonal AC as we did previously in theorem 8.1. The same procedure I am going to follow here. We are going to take the triangle ABC and ADC. I am going to prove that these two triangles are congruent. Marking the angle BAC as 1 and BCA as 3 and DAC as 4 and DCA as 2. Now coming to the proof, in triangle ABC and DCA, AB is parallel to CD and AC is a transversal. I can show that angle 1 is equal to angle 2 by the alternate interior angle. Similarly, BC and DA are parallel line. AC is a transversal, so that angle 3 and angle 4 are equal. They are alternate interior. I got angle 3 is equal to angle 4. I find the third one, AC is a common side. So two angles which lies on the side AC. So I can use ASA congruence rule. Triangle ABC is congruent to triangle CDA. Practically, its corresponding sides AB is equivalent to CD and AD is equivalent to BC, since they are corresponding parts of the congruent triangles. Theorem 8.3. If each pair of opposite sides of a quadrilateral are equal, then it is a parallelogram. He has given a parallelogram ABCD. If the opposite sides are equal in the length, then the quadrilateral becomes a parallelogram. So here he has given a quadrilateral ABCD with opposite sides are equal in their length. We want to show that this quadrilateral becomes a parallelogram. So coming to the solution, given a quadrilateral ABCD in which AB is equal to CD and AD is equal to BC. So we need to prove that ABCD is a parallelogram. So we are doing the construction, join AC diagonal. Now let us consider triangle ABC and triangle ADC. So we are going to prove that these two triangles are congruent, where AB is equal to CD and BC is equivalent to AD and AC as a common side. So I am writing here AB is equal to CD. It is already given in the problem, and BC is equal to AD and AC as a common side. So by SSS congruence rule, triangle ABC is congruent to triangle CDA. So I am writing angle BAC is equal to angle DCA by CPCT. So I am going to use the converse of alternate interior angle theorem. If two lines are cut by a transversal and if you find that the alternate interior angles were equal, then those two lines are parallel to each other. So I get AB is parallel to CD. Similarly, I can show that AD is parallel to BC also. Hence, ABCD is a parallelogram.